Okay, we're going to wrap up our talk on equivalent fractions by looking at our last part, which is fraction as division. And this is the first time we've actually used the word division. But let's take a look at the original definition of what a fraction is. We have written down from before it is m over n is equal to m copies of 1n. That was based on knowing the unit segment, which was 0 to 1. Well, our new theorem is going to look at the fraction a little differently, something that you might be a little bit more familiar with. And that is to say, for any fraction m over n is the length of one part when the line, or when a segment of length m is partitioned into n equal parts. Well, instead of being based on 0 to 1, now it's based on the actual length of 0 to whatever your line length is. Let's say, for example, 5/3. We're going to use 5/3. So this is based on this line segment of 0 to 5, and we've got a number line here. So what this is saying is we are going to look at 5/3. We're going to take the line segment, which is 5. And that is going to be equal to, think of what is this partitioned into. If I have a line segment from 0 to 5, well, we haven't partitioned it into anything other than segments of 1. So we're going to write this as 5 copies of a segment length of 1. Well, if we're going to split this into 3 groups, then what we're really doing is this is going to be using our equivalent fractions. We're going to partition it into 3 groups. All right, so now what we have is we're going to split this up into 3s. But we need 3 groups of these, so it's going to be 1, 2, 3, 4, 5. Here's our first group. Oh, I'm sorry, right here. Then count again, 1, 2, 3, 4, 5. And our last group, 1, 2, 3, 4, 5. So what we end up having is, if these are concatenations of thirds, 1/3, 2/3, 3/3, 4/3, well, lo and behold, what do we have? 5/3. So we can look at this as division by saying that 5/3 is the same as saying 5 divided by 3. And we'll finish this up in the next video.